Welcome, scholars. Today's lesson is on theoretical probability. My intention for you today is just to go through these 16 scenarios with you. And when we get done doing that, you'll have a chance to work on some of these independently, as well as ask questions in class as long as we have time remaining after the video. Uh, Theoretical probability is relatively straightforward in the sense that we're really thinking about out of a set number of equally likely outcomes, like different events that all have the same probability of occurring. How many of those situations are described or fit the condition that is described? So, for instance, here on the first one, rolling a number less than 4 on a number cube. Well, a number cube is just a die. So you have 6 sides on your die. In this case, how many of them are less than 4? Well, that would just be this cluster here. And within that cluster, there are 3 different choices out of 6 sides on the die. So the theoretical probability that we'll get a number less than 4 is 1/2. We could also express that as a decimal and divide it out, 0.5. And we can also move that decimal 2 spots to the right and say it's 50%. I will typically use the fractional form. I usually reduce, but honestly, if you don't reduce it, it's not that big a deal. It's just a little easier to make sense of the value once it's in its simplified form. All right, scenario number 2. Randomly choosing a day of the week, and it's a weekend. Well, in 1 week's time, you have Saturday and Sunday that would be classified as the weekend. So that is 2 choices out of 7. Number 3, spinning red on a spinner with equal sections of red, blue, and green. Well, if you have 3 sections and we want to only choose one of those sections, that would be a 1 in 3 probability. Number 4, randomly choosing the letter N from the letters in number. Well, there is only one N, and we have 1, 2, 3, 4, 5, 6 letters. So you would have a 1 in 6 chance of choosing that letter. Does that mean every 6th time you're going to get it? No. We showed that with the card experiment in class the other day, but that's really what we're dealing with here. So the probability that it will snow is 60%. What is the probability it will not snow? I'm going to have you cross out this top one here. So when they say the probability of something not happening, we're just going to take 100% as our total, and we're going to subtract out the probability of the event actually happening. If it's in decimal form, you can also think of that as 1 minus the probability of the event occurring. So here, let's see what form we're in. Here we're in percentage form, so we would say the probability of it not occurring would be 100% minus 60%, which gives us 40%. Okay. Number 6, the probability of tossing 2 coins, having them land heads up is 1/4. What is the probability it will not? So this is the same idea. So we're taking away 1 minus 1/4. Not going to do 100 this time since we're not in percentages. And that leaves me with 3/4. Okay, on number 7, we have a spinner with 1, 2, 3, 4 different colors. When you look at the probability of each event, they give us 3 out of the 4. What we want to do is make sure that this 4th one that we don't know is what makes it add up to 100%, or in decimal form, we'll say 1. So they gave us 0.4 for the red one, 0.05. I'm going to always line my decimals up when I add, and 0.25 for the third one. So let's see, those 3 together already make up 0.70, which means if it's out of 100%, 70% of it is composed of the other three colors, which means 30% or 0.3, which is what we get when we take 1 minus the 70% that we've already used, or the 0.7. So it would be 0.30. You could also say 0.3, and that would be accurate as well. All right, the next one. Miguel entered a contest offering prizes for the top 3 finishers. The probability of winning first is 12%, and second is 18%, and third is 20%. What is the probability he will not win? Well, this one's very similar. These are the 3 scenarios we know. Of the other options, we just need to know that all of the scenarios have to add up to 100%. So we've used, 12%. We've used 18% and 20%. So I'm just going to add those together. And together that adds up to 40. So basically there's a 40% chance you end up in the top 3. Otherwise, what percentage is left? Well, 100% minus 40% would be 60%. Okay, don't overthink these questions. They are not meant to be trick questions. Now, I say that with caution because number 9, 10, and 11 and 12 are all a little bit different. Notice these questions have a word that stands out that's slightly different than before. Okay, this odds idea is a way different concept than probability. Okay, there's some similarities, but odds are not written as part out of total. So I'm going to have you write that up here. It is not, let me get my pen selected here. Odds are not the part over the total. Okay, instead, odds describe 2 scenarios. Okay, odds, the way that they work is that there's 2 blanks. So there's a number here, and then you'll have a colon, and then you'll have another number here. They usually don't write it in fractional form. They usually write it with that colon. Okay. The first blank, I'll make this a little bigger so I can write in there. The first blank that you're going to see here represents the number of choices, and I'll move this down. The number of choices that fit the description. So whatever the problem is describing, the number of choices that fit that description go in the first blank. Okay, and then in the second blank will be the number of choices that do not fit the description. In other words, all the other choices. How many of them there are. All right, so let's go down here. So it says the odds of winning a contest are 1 to 50. So that means that one person is going to be a winner. And then we have 50 people. 50 people will lose. Second number is not the total number of people. So in this case, the total number of choices or people here would be 51. Okay? So if they want us to write a probability of winning the contest, well, you have to think part out of total. So in this case, the part goes over the total. All right, well, in this case, the part that applies, they want to know the probability of winners. There's only one that won out of a total of 51. So odds, you have to really add the 2 parts together to determine the total number of choices. Okay, so here on number 10, It says the odds of a spinner landing on yellow are 3 to 1. That basically means that 3 of the spots are yellow and 1 part is not yellow. So I'm going to write that in words first. So 3 are yellow. 1 is, I'm going to put not yellow. Which means my total here is 4. So what is the probability that they will not land on yellow? Well, if you look over here, 1 of them is not yellow out of a total of 4 parts. Again, notice when we go to probability, we had to take these two values, the 3 and the 1, add them together, and that becomes the total parts. All right. Number 11. Okay, so this one says probability. So we're kind of working the game backwards. Now they're starting with this value, and we have to turn it into something like the 3 to 1. So let's see how that's going to work. Probability of a thunderstorm. So probability is part out of total. So I'm going to rewrite that as 80 over 100. All right, so 80%, 80 out of 100 times there's going to be a storm out of 100, which is my total. Okay, so if they want the odds that there will be a thunderstorm, the odds of a storm always talk about how many times it will storm compared to how many times it won't. So I'm going to put, I'm going to write that in words. Will, colon, will not. So will storm. Notice we're not using the total here. So here, what percent of the time will it storm? Well, 80% of the time it will storm. Colon, how many times will it not storm? Well, if there's 100% total and 80% does include storms, 20%, the other part remaining out of 100, would not be storms. And I'm going to reduce that to 4 to 1 because those are divisible by 20. We can reduce it down. Okay. Number 12. Odds of selecting a green card are 2 to 5. So I'm going to say 2 are green, 5 are not green, which means if I add those, I have 7 total. So the question asks, what is the probability of not getting a red? Well, here we have it. 5 of them are not red. There's 7 total, so our probability is part that describes the scenario over total number of choices, 5 out of 7. And again, notice they started with odds of 2 to 5. I had to add those together when I convert to probability. All right, 13 through 16 is really just working on notation. So probability of event A, well, if you look at A, there were 5 times that letter A was chosen. And then to figure out how many times this occurred, we're just going to add these up right here. So I'm going to say 9 plus 6 is 15, plus this adds up to 10. 15 and 10 is 25. So I would say the probability of event A is 5 out of a total of 25. I'm going to reduce that to a fifth. I'd be okay if you didn't reduce, but it's kind of an easy set to work with, so we're going to do that. All right, now the nice thing is the total doesn't change. So when we're dealing with probability, it'll always be part out of total. So here, for letter B, 4 times letter B was chosen out of a total of 25 draws. Okay, now what do they describe with odds? So they want, in this case, the first number will be the amount in favor, and the second number will be the amount not in favor. All right, well, let's see what happened. How many were in favor of C right here? There were 6 of those, 6 out of 25 that were in favor of C. How many were not in favor of C? Well, if there's 25 total, that means there are 19 left over. Those don't reduce, so I'm going to leave it like that. All right, now, the last one, odds against E. So the first, whatever they describe comes first. So I'm going to say odds against E come first, and then all other choices come second. So odds against E. Well, if there were 8 that were in favor of E, that tells me that's my second number. 8 were the ones that were for E. So how many were against E? Well, whatever's left out of 25, which would be basically, let me get an eraser here. So all of these are against E. These are the ones that are for E. So here that goes as your second number. Okay, hopefully that helps. Your job is to complete the assignment. Your assignment looks like this. There is a front and a back, but that's mainly just because I copied and pasted from the textbook. So you should have plenty of room to do your work. All right, let me know if you have any questions. Thanks.